tayo, TV Broad.
Ano ba yun? Kung stats yan, ayoko na. Alam ko na yan eh. Nunood ka lang para sa crush mo eh. Di mo na inaaral.
Bili na kasi, te. Delivery na kita ng pagkain pagtapos.
Di. Tayo.
Today, our topic for today is population standard deviation. Standard deviation shows how spread out the data values are from the population mean.
Ibig sabihin, sinusukat kung gaano ka consistent ang buong population.
So parang kung pare-pareho kayo ng score.
Exactly.
When the population standard deviation is small,
May infer natin na malapit sa mean ang data, kaya stable at consistent ang population.
So parang walang pasaway sa score.
Ganun na nga.
on the other hand, a large population standard deviation
Ibig sabihin, malayo ang value sa mean, kaya malaki ang variation sa population.
Di may mataas, saka may mababa.
Oo, ganun nga. Galing mo, Heart, kukuha mo na.
These also tell us how predictable population is.
Tignan mo. Kapag low deviation, predictable ang performance. Pero kapag high deviation, unpredictable.
Parang yung mga quizzes ko lang.
Tama. Ikaw yung example. So, anong inference mo dito?
Kapag maliit yung population standard deviation, pare-pareho ang population. Kapag malaki, iba-iba yung performance. Kaya mas maraming extreme variance.
Galing. Carry mo na pala to eh. Oh, tapos na tayo ah. Tara na.
Numbers tell stories, but do you really know how consistent that story really is?
Here, students examine data, compare findings, and look for patterns. They question results, analyze differences, and learn that numbers don't always behave the same way. It starts with curiosity, asking questions and looking for answers beyond the obvious.
Using statistical tools like the chi-square distribution, we determine if variability meets standards. Is the production consistent? Is the data reliable? Is there a significant difference between groups?
Because in this world of statistics, precision matters. Inferences for population standard deviations measure the unseen, decide with certainty.
Ang susunod na programa ay rated PG. Patnubay at gabay ng magulang ay kailangan sa mga batang manonood.
Good morning, kids. I am your teacher, John Jeric Paracas. And now, let's have a very quick review. Standard deviation tell us one thing: how spread out numbers are from the average. Imagine two classes taking a quiz. Class A scores 88, 89, 90, 91, and 92. And Class B scores 50, 100, 70, 95, 6, 6, 7. Which class has scores that are more spread out? Yes, Class B. That means Class B has a bigger standard deviation. Small spread equals to small SD. Big spread is equal to big SD.
Now, listen carefully to this word. Independent. Independent means that two groups do not affect each other. Example, if I test School A and School B, students in School A are not copying School B. They are separate. That means the samples are independent. If they were the same student, tested twice, that would be not independent.
Now, here's the big question. What if we want to compare two different groups? For example, boys versus girls test scores.
School A versus School B, brand X batteries versus brand Y batteries. We are not comparing their averages. We are comparing their spread. We're asking which group is more consistent. That's when we compare two population standard deviations.
Go.
The F-test compares two variances. Variance is just standard deviation squared. So here's what we do. We take variance of group 1 divided by variance of group 2. And that gives us something called the F value. Formula looks like this. F is equal to S sub 1 squared divided by S sub 2 squared, where S sub 1 variant
When we are compared to population standard deviation, we are trying to answer this. Is the one population more variable than the other? Or they are basically the same? To test this, we use something called the F-test. Yes, just the letter F. Not scary, just F.
Ang susunod na programa ay rated PG. Patnubay at gabay ng magulang ay kailangan sa mga batang manonood.
Mama teacher told me it's alright. We were solving through the problem times. Sleepless with the stars all night. But now the graph is so polite. Oh, 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 oh my Lord. Never read results like this before. We had to make our own insights from sample trends and data, right? Oh, 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 oh.
Good day everyone, you are watching Statistically Yours production. Today we will talk about inferences for population standard deviations. This topic helps us understand how spread out data is and how we use samples to make conclusions about the population.
Good morning, Heart. Now, we are live at Malabon National High School. Let us begin with the definition. Population standard deviation tells us how far the data values are from the average of a population. When the standard deviation is small, the values are close to the mean. When it is large, the data values are more spread out. In this topic, we use inference. This means we use sample data to make a conclusion about the population standard deviation.
To make it clear, let us look at a few examples. For one population, we may want to know if the scores of a class are consistent. We take a sample and analyze how spread out the scores are. For two populations, we may compare two groups. For example, we can compare the variability of scores from two classes or the consistency of products from two factories.
Now let us talk about the application. Population standard deviation is used in real life. In manufacturing, it helps check if products are consistent. In education, it helps analyze how varied student scores are. In research, it helps compare data from different groups. A good case example study on speaker woofer driving manufacturing, where standard deviation is used to check products' quality.
Overall, this topic shows that statistics is not only about numbers and formulas. It helps us understand real data and make better decisions using samples. Thank you for watching Statistically Yours.
In this video, we're going to talk about how to perform a hypothesis test. With a single variance given a chi-square distribution, so in this problem, the standard deviation of exam scores in the math department of a local college is 8.6. A professor believes this value to be less. He samples 20 exam scores and finds that the standard deviation is 6.9. This sample Thus, the sample provides enough evidence to suggest that the true standard deviation is less than 8.6. Let's use a significance level of 5 or 0.05. So let's write down what we know. So the standard deviation, the hypothesized standard deviation is 8.6, which means the hypothesized variance is 8.6 squared. The sample standard deviation is 6.9, which means the sample variance is 6.9 squared. The sample size is 20, and the degrees of freedom is n minus 1, which is 20 minus 1, so that's going to be 19. The next thing we need to do, write the null hypothesis and the alternative hypothesis. So for the null hypothesis, we could say that the variance is believed to be 8.6 squared. For the alternative hypothesis, we believe, or the professor believes, the variance to be less than 8.6 squared. Based on what we stated here, now we need to determine what type of test we have. If it's a left-tailed test, a right-tailed test, or two-tailed test, what would you say? So looking at the alternative hypothesis, because the professor believes the value to be less, this is going to be ulit nga. So looking at the alternative hypothesis, because the professor believes the value to be less, this is going to be a left-tailed test. So let's draw the chi-square distribution for that. So it's going to look something like this, but the area that's going to be shaded will be to the left. So this area is going to be our alpha value. So the area of the shaded region is going to be 0.05. The area of the non-shaded region, or the area to the right of our critical chi-square value, that's going to be 1 minus 0.05, which is 0.95. So this here, the small area, that's going to be the rejection region. Now, if our calculated chi-square value falls in this area, we are not going to reject the null hypothesis. But if it's a less than a critical value highlighted in red, we are going to reject the null hypothesis. So let's find our critical values. So we have 19 degrees of freedom with an area to the right of 0.95. So here we have the chi-square distribution table, and we said that we have 19 degrees of freedom, and the area to the right of the critical value is 0.95. So this is the intersecting value. So our critical chi-square value is 10.117. So let's go ahead and put that number on the graph. Now our next step is to find our calculated chi-square value based on our sample. Now our next step is to find our calculated chi-square value based on our sample, and here's the formula that we're going to talk. Now our next step is to find our calculated chi-square value based on our sample, and here's the formula that we're going to use to get that answer. So it's equal to n minus 1 times the sample variance divided by the population variance, and we're going to use the hypothesized population variance. So n minus 1, that's 20 minus 1 times s squared, which is 6.9 squared, over sigma squared, which is 8.6 squared. 19 times 6.9 squared divided by 8.6 squared gives us 12.23. So 12.23 is somewhere to the right of 10.117. So therefore, we will not reject the null hypothesis because it's in this region, which is the do not reject the null hypothesis region. So therefore we can say that this sample does not provide enough evidence to reject the null hypothesis, since our calculated chi-square value exceeds our critical chi-square value. given that we have a left-tailed test.